Welcome to Stefan Neugebauer, Chairman of AirTrack and Equia, Edel Sheridan, Senior Business Developer at Sintef Energy Research, and Thomas Fabian, Director Commercial Vehicles at ASEA. Thank you for joining us today.
But before we get right into the discussion, let's first have a look together at our short EUCAR video and some of the key projects in sustainable mobility.
Sustainable mobility. EUCAR strives for sustainable, safe, clean, and efficient road transport for people and goods, providing freedom of mobility to all, with benefits to users and society, enhancing quality of life. A climate-neutral continent by 2050 requires a systematic approach for mobility and the energy sector, with efficient, feasible, and cost-effective renewable energy carriers and their sustainable production at economies of scale. Depending on the mobility use case and the related requirements for energy density and storage, various options such as batteries, hydrogen, or other renewable hydrocarbon fuels are to be considered. For road transport, powertrain electrification certainly plays a fundamental role to achieve well-to-wheel carbon neutrality. Highly electrified technologies, such as plug-in hybrid electric vehicles and range-extended electric vehicles, are important solutions in the technology mix. Together with battery electric vehicles and fuel cell electric vehicles technologies, they will provide a range of solutions, further reducing carbon emissions in road transport and helping to achieve our climate targets and the European Green Deal. EUCAR members lead and cooperate in R&I projects towards more sustainable mobility.
The AeroFlex Project Consortium develops new technologies and architectures for long-haul trucks. These novel vehicle concepts will significantly reduce the carbon footprint from road transport, while matching infrastructure and system requirements. The JEC Well-to-Wheel study is a long-standing collaboration between the European Commission's Joint Research Centre, EUCAR, and Concave. The survey analyzed future fuels and powertrain combinations in terms of consumption and emissions. The NEMO project aims at making electromobility more user-friendly. It shows the availability of charging services for better route planning by cooperating with network and infrastructure stakeholders. The GHOST project improves the electrical, mechanical, and thermal architecture of batteries for BEVs and PHEVs, thus increasing the range, lifetime, functional safety, and reliability of the batteries. The Long Run project accelerates the transition from conventional fuels to alternative and renewable fuels by decreasing pollutant emissions from heavy-duty vehicles. To achieve this, the consortium will develop and demonstrate different engines, drivelines, and full vehicles, further reducing emissions. The ORCA project reduces the total cost of ownership for hybrid electric distribution trucks and multi-modular buses, while improving the efficiency of the hybrid powertrain. This is accomplished by optimizing renewable energy sources and right-sizing the engine, while at the same time increasing the pure electric driving range.
Great. With this introduction, let's get right started with Stefan Neugebauer. And dear guests, please continue to use Slido for your comments, reactions, and questions. Stefan, welcome. The stage is yours.
Thank you very much, Ilka. And you are absolutely right. We are all committed to achieve a carbon neutral road transport in 2050. And we have to achieve this from a well-to-wheel perspective. And the technology platform AirTrack has on board all the different stakeholders. So we prepared a study for carbon neutral road transport. It's highly complex. It's fully available, the study, on the AirTag homepage, but I would like to give you some insights for this study. And if you can go to the next slide, please, you can see the concept of this study. So we tried to define different scenarios and combined them. And when you look at the top left, you can see we have defined 3 powertrain scenarios. Maybe extreme scenarios, but this is important because we want to see the differences. And we have a highly electrified powertrain scenario. Only BEV and plug-in hybrids will be on the road in 2050. We have to consider the existing fleet. We have a highly electrified scenario, including the use of hydrogen and fuel cell. And we have a hybrid scenario where we still use some combustion engines, hybrids with renewable fuels outside of the urban area. So maybe someone says, no, this is not in line with the European policy, but we are research and we are free in mind and we want to see the difference between the scenarios. And then we have to combine this with efficiency potentials, which we can achieve up to 2050. Better vehicles, better traffic conditions, traffic reduction technologies. And so we can have an optimistic and pessimistic view for this. And then we have to combine this with different fuel production paths. You may say, oh no, in 2050 we will not have any fuel anymore. Sorry, this is not realistic. When you think about the existing fleet, there will be a need for fuels. And so we defined 4 different scenarios for renewable fuels. Scenario with advanced biofuels, an e-fuel scenario, and a mix of this, and then a scenario where we still use a little bit of fossil fuel. So you might say, oh, terrible, no fossil anymore, but you can be relaxed because at the end, all these scenarios and all these combination of scenarios are at the end, finally, CO2 neutral. And we want to see the differences and what happens if we go in the one or the other direction. So if we go to the next slide, please, you can see that we created a full system for the well-to-wheel system approach, describing all the different steps. And we start on the left side with wind and solar and other renewable resources producing electricity. And then this electricity we have to distribute, and we can directly give it to the vehicle for battery electric vehicles. Or we can, if you go to the down, you can see we can also produce hydrogen by using the electricity and give it to the vehicle. Or if we give biomass into the system on the top, biomass together with electricity, we can produce advanced biofuels, give them to the vehicle, and so on and so on. And all these scenarios at the end are totally CO2 neutral. And by doing this complex system, by simulation of the system, we can ask and we can answer important questions. And now I would like to give you an insight for 3 questions. If we move on to the next slide, please. One question is from the vehicle perspective, how much fuel or hydrogen or electricity could be required in the European road transport system in 2050? So if we look at the fuels, then we can see that we will achieve dramatic and very, very good savings. 60% also in a hybrid scenario and up to 95% if we are talking about highly electrified scenarios. This is important because this opens the possibility to use renewable fuels because we do not need so much of them. If we look at the electricity, then the XEV, the battery electric vehicles, the plug-in hybrid vehicles, they consume directly up to 35% of total EU 28 electricity electricity consumption in 2019. So this means we try to compare this. Our starting point is the overall electricity production and consumption in 2019 in Europe as a whole. And we need up to 35% in addition to that for the electrification and for the electricity directly in the vehicle. But if we consider also hydrogen, this has also to be produced by electricity, then it will be more. And what we can also see is that the efficiency of the whole system and the efficiency of the vehicle has a big influence. Up to 50% can be influenced by efficiency measures. This is an important message for the research, because research on efficiency is more or less always done by incremental steps. But at the end, they have a huge leverage effect. If we move on to the next slide, please, you can see the question, and for me, it is one of the most important questions. How much electricity is needed in the overall scenarios? And electricity will be the bottleneck for sure, because all sectors are going for electrification. And here, what we can see is that in highly electrified scenarios, the electricity need is between 35 and up to 50% of the more or less today's electricity consumption in Europe as add-on. And if we think about hydrogen, it will be more. And if we think about advanced biofuels, it goes down. Why? Because the advanced biofuels, they bring electricity and energy into the system, the biomass energy. So the advanced biofuel scenario is very attractive. The electricity needs goes down to the level of 20 up to 30% in addition to the today's production. And so I'm very happy that they also took this scenario, because it makes sense to think about this. If you go to the next slide, please. One of the normal questions is, what is the best fleet and fuel combination? But to be honest, this cannot be answered based on this study, because it's a scenario-based approach, scenario with no optimization. And there are many questions not asked and not answered by this study. And you can see these additional important topics on the right side of this slide. We must consider the production and storage capacity. We must consider the life cycle assessment, not only for the energy and infrastructure, also for the vehicle production. We must consider the investments in infrastructure, the cost of energy production and distribution, the technology development, the land use, the water use, the needs for resources, the different locations for energy production. Are we limited to Europe, or do we use Middle East and North Africa areas where we have a high potential for producing cheap electricity? So you can see that it is very complex, and therefore I have my doubts if we in the political level we say now this is the one and the only solution, because you can see here the complexity. If you move on to the next slide, please. I would like to come to the conclusions. The next slide, please. So, first of all, there are many different ways are possible with for carbon neutral road transport, and they have significant consequences in specific when we look at the electricity demand. But there are many different ways. All these ways, they need drastic changes in all three areas: the vehicle technology, the infrastructure, and the energy production. And for the complete and robust carbon neutrality of road transport, we should have a mix of technologies. You can also say a competition of technologies where electrification is a key element. That's absolutely true, but it's a key element and we see different pillars in addition to this. We see the XEV, the hybrids, the renewable fuels, and the fuel cells. And why do we need these different pillars? Because the mix of these powertrains options will strongly depend on the development of the infrastructure. And it's unclear what will be the situation in the infrastructure. But what is clear is that the infrastructure will be very, very different in the different areas of Europe, and if we are talking about the urban or the rural areas. So let us go to the next slide, please. These are the takeaways I would like to give to you. First of all, efficiency is paramount, independent from the scenarios we are talking about. Efficiency is always important. Second, the total demand for electricity in road transport will increase. It will increase in a significant way. If you compare it with today's overall electricity consumption in Europe, and if we think about the highly electrified scenario, it's around about 35 to 50% more. Including hydrogen, it's more. If we are talking about a system where we also introduce advanced biofuels, the electricity demand goes down in a significant way. We are talking now about 20 to 30% of overall electricity production in Europe. If we are talking about e-fuels, then we need much more electricity. But these e-fuels, they could be produced outside of Europe where electricity is available and in a very, very cheap way. Then the decreased demand for fuels opens the possibility to use renewable fuels. And last, the largely carbon neutral production of electricity. It's a prerequisite for carbon neutral road transport. If the electricity is not carbon neutral, all these exercises don't make any sense. So having said this, I would come to the last slide, please. I would like to thank all the experts from different stakeholders in the air truck community. Thank you for preparing this very, very complex study. And once more again, if you are interested in the details, the study is fully available on the air truck homepage. Thank you very much.
Perfect. Thank you, Stefan, for this clear and comprehensive presentation. A holistic understanding is so important when we have to do it right. Edel, before we come to your presentation, could you briefly reflect on Stefan's intervention?
Firstly, I very much welcome this study. It's absolutely essential that we have this holistic view. There are some points you touched on that are really interesting. When you talk about efficiency, I mean, batteries are one of the most efficient technologies out there that we can utilize. When you speak of increasing our electricity, that the demand will increase, that is so true, and we are seeing this. So the development of solutions such as offshore wind and really building out the grid is absolutely essential if Europe is going to do this. You mentioned about e-fuels, that perhaps that they require a lot of electricity to produce them, and perhaps they could be produced in countries that have outside of Europe. I would question that and say maybe we should really look at producing these inside Europe, because we need to have a certain level of independence when it comes to fuel, of course. So this, of course, is always an issue that needs to be addressed. And it also comes up in the battery area, where we're trying to set up a huge battery manufacturing initiatives in Europe. So I very much welcome this study. I think it's really excellent, and it's a good analysis. And as you say, there's a lot more work to be done. Certainly looking at the LCA and looking at the overall, getting down into the details of the life cycle. Thank you.
All right, thank you indeed. And Thomas, what did you learn from Stefan's presentation?
Thank you. I think it's a really valuable and important contribution. Very short, I think what matters is cutting the total emissions in the real world from road transport and making this fast. And there are obviously a number of potentially competing approaches here and technologies, but the key message is that we really need to make this happen fast, and we need to apply all the measures that we can think of in the most smart way possible. So key takeaway, focus on what really matters, cutting the emissions fast, so making the smart choices.
Thank you, Thomas. Great. So now let's continue with Edel. Advancing battery technology is undoubtedly playing a significant role in the future energy and mobility system. We are so excited to hear more about this crucial topic and what is happening in Europe. Edel, the floor is yours.
Thank you very much. There is so much happening in Europe when it comes to battery technology. As I mentioned, or perhaps I didn't, that I'm the technical leader in the Batteries Europe network, where we have around about 600 experts working together to design the strategic research agenda on batteries. So we really feel that sustainability is at the heart of the battery industry, and we have also really dedicated a task force to looking at this topic of sustainability. Just to comment, I'm based in Sintef. I join you from Sintef from Trondheim in Norway. And in Trondheim and in Norway, we have the highest EV ownership. So we are really having some experience with this and seeing what it is like for a country to really have a lot of EVs. So if we could go to the next slide. So just a very brief overview. As you know, battery technology is a very complex value chain involving a lot of different challenging areas. From the raw materials, advanced materials, the actual manufacturing itself, all the way through to the applications, which are becoming more and more into different sectors, and then back to recycling and reuse. While it's a broad value chain that presents a lot of different challenges, it also presents a huge number of opportunities, because if we can take each part of this sector and introduce greater components of sustainability and efficiency, as Stefan referred to earlier, we really can make this really a sustainable and competitive industry in Europe. So this is quite important. So the next slide, please. So I had the fortune of attending the COP meeting last week in Glasgow, and at COP there were 2 sessions held on batteries. That really says that this is an important area. The IEA had a session that was on developing sustainable battery industry that can deliver on climate ambitions. This was a very interesting session. The European Battery Alliance's Ilke van Dalwijk presented and gave quite an overview. And also we had a presentation by Frederik Hauge, who is from Bologna, that are involved in a battery factory initiative in Norway that is looking at how we can produce, well, I say climate neutral batteries in the production process. So it's looking at ways of looking at in the development processes, in the energy processes, how can you reuse heat? Can you use CCS, for example, in the different various processes? There was another session held by the US Center on Transport, and in this session they mentioned that they have a new blueprint document that came out. It is the National Blueprint for Lithium Batteries. This was also quite interesting to hear about. They also are focusing on sustainability, so it is not just a trend that is in Europe. So if we could go to the next slide, please. So just briefly, in Batteries Europe, as I mentioned, we're quite a large community for battery R&I, and we have the task of preparing several key strategic documents and really also supporting BEPA, which is the Battery Partnership, which helps to determine what should be in the Horizon Europe program. So we kind of support them and support the battery industry as a general. We produce a strategic research agenda, technical roadmaps, position papers, and also we're looking at reporting methodologies. We've had 4 task forces on sustainability, safety, skills and education, and digitalization. Our sustainability task force has prepared a paper which is available on the Batteries Europe website, and it looks at the 3 different dimensions: the economic, social and environmental. So what I present here today is what has been developed by the task force, and I have to say I'm very grateful to all of them for working in this. So if we could go to the next slide, please. So as I mentioned, it's very important across the entire battery value chain to look at sustainability. You can't just take one area, make it sustainable and think it's going to be all fine. You really have to look across the entire value chain. And as Stefan presented earlier, you have to take this holistic view to the system. I mean, it brings a high level of complexity, but we have to make sure that does not slow down the development in this industry and making transport carbon neutral. We really have to ensure that we don't have it as an Achilles heel, this level of complexity, but that we come over it. So some of the economic factors we really looked at are the new sustainable business models. And there's a lot of regulatory changes coming now. For example, there's a new battery regulation that is in preparation and a very advanced stage. There we're looking at, for example, the recycling, the raw materials supply, and a lot of different factors that are going to have some regulation within them to the battery industry. While this regulation is good to get sustainability, we have to ensure it's not going to be a stumbling block. So there really needs to be a focus on sustainable business models that fit in, that work with the regulation and vice versa. I think one of the areas when we talk about batteries that everyone is concerned about is the availability of the raw materials and also the cost of the actual battery and the technical performance itself. So we need research really to extend the performance and the lifetime of batteries to make the more sustainable business models for batteries. As in all situations, there are geopolitical considerations which must be thought about. Also, there are the sustainability of imports and the circular economy and recycling. So from an economic perspective, there are many areas to address. The social perspective, of course, naturally, when we've talked about raw materials, as many people know, there have been problems with some of the raw materials used in batteries earlier, particularly I mentioned cobalt. There is a very strong focus now on ensuring that workers' rights and social aspects are addressed along every part of the value chain. So while earlier there was not so much focus on the social LCA, this is coming along now. Also for the safety of the workers we look at, and also social acceptance and uptake. This is another aspect that must be reflected on in sustainability. So we really need to explain that this technology works, we need to demonstrate that it works, and we need to demonstrate it that it's safe also. And of course, when we come to environmental, this is what people usually first think of when they think sustainability. We're looking at the carbon footprint, the greenhouse gas emissions, and the resource usage. So here, it is a huge advantage if we can produce batteries using green energy from, when I say green energy, renewable energy sources. So this is an important factor to take into consideration. I've touched on these very quickly, but I'll move on because time is a bit limited. So the next slide, please. One of the concepts that were kind of brought out when the group on sustainability was formed was this idea of looking at a new sustainability level or label for batteries. There is a lot of work gone into eco-labeling, and the battery regulation will certainly help that. But also this idea of sustainability labeling. This is already in the textiles and the food industry. It takes a broader view on sustainability. It looks at the ethical, social and environmental indicators collectively. So the next slide, please. So just some of the conclusions from the task force. Sustainability is really a key factor in the green energy transition. There is no point in producing batteries that are not produced in a sustainable way. We need, and driving them around and saying we have a sustainable automotive sector. we need to have batteries that have as low as possible CO2 footprint and environmental footprint. They also need to be competitive. So competitiveness needs to come hand in hand with sustainability. And this we must remember in the development of regulation. This is also when we're looking at traceability, low impact production and recycling, and also extending the lifetime of the battery. I want to just touch on one example where we see some issues. For example, the recycling of batteries. It was pointed out in one of the US documents that the recycling of batteries, half the cost of that to the recycler can be the transport of the batteries because they're hazardous goods. We have to do something to address issues such as this in order to enable the industry to be sustainable while being competitive at the same time. So lots of research and innovation is still needed for the future battery system to improve the performance and lower the environmental footprint. There's a lot we can do. Competitiveness and sustainability go hand in hand, as I said, and we really need to speak to our end customers. And I think this is where it's very important that we collectively work as the panel here today, for example, that we really show the end customer that we have a sustainable product. So the next slide, please. I'm just going to take up a couple of R&I actions that have been taken place that are underway. So what are we actually doing about sustainability? There was a call that closed, a Horizon Europe call that closed in September. It was a joint call between BAT4EU, which the Battery Partner European Partnership, and 2.0. And this joint call looked at LCA and the design and sustainability, sustainable circularity. So we expect this call will be very helpful in providing more of the information to complement, for example, what Stefan has described. Also in BEPA, the Battery European Partnership Association, so we call it BAT4EU when we're working with the European Commission, and BEPA when it's working as the association as such. There have been topics that are being looked at is design for circularity. And these are kind of broader ideas looking at new business cases, including second life and direct recycling. And also we realise that we need to work on digital tools for traceability and risk assessment in order to really make the battery regulation very workable. So that is all I have for you today because the time is limited. I hope I give you a little snapshot of what's going on in the battery world. There are so many things to do. It's a very exciting time to work here in this particular field. And I believe we need to work together to deliver a good, clear message to our politicians and also to the consumers at home that we can have sustainable batteries and sustainable transport system. Thank you.
Thank you, Adele. Thank you so much. Research and innovation in batteries and strengthening the industrial value chain is key. So I'm curious to hear from the other speakers whether you agree. Maybe Thomas, you can start with your short comment.
Of course, fully agree with this. I mean, again, very short in the interest of time. It's complex. It's obviously complex, this transition, but it's being addressed across the value chain. And this is what we need to do in a smart way again to ensure that the sustainability is the key factor across the whole value chain.
Thank you, Thomas. And Stefan, is there anything you would add to this?
Yes, Edel, I was very happy that you mentioned the 3 dimensions of sustainability and also the dimension of economic aspects. Because if it is if something does not work in an economic point of view, it is not sustainable. And this is very important for automotive industry because we are not a national industry. We are not a continental industry. We are a global industry, and therefore the batteries must be they are in a global competition. So thank you for this.
Thank you, Stefan. Now, how is the situation for the heavy vehicles, the trucks and the buses? What is happening there and how can innovation contribute to achieving the Green Deal targets? Thomas, please give us your perspective on this highly relevant topic.
Thank you so much, and also for the invitation, of course. It's the key question: how do we reach climate neutrality in road transport, specifically with heavy-duty vehicles? Next slide, please. Now, next slide, please. In road transport, we're facing two main challenges. One is the fact that we have seen growing CO2 emissions over the last decades. Vehicles have steadily but gradually become ever more fuel efficient over the years, but these efficiency gains have been compensated by growing transport demand. Making vehicles more efficient has always been the top priority for the truck industry. This is a key competitive factor. But cutting emissions by a few percentages per year is not enough anymore. Next slide, please. The second big challenge is the average age of the vehicle fleet, and that has been mentioned already by Lars earlier today. The average age of the truck fleet in Europe today stands at about 12.5 years. There's quite a spread between different vehicle segments and obviously different member states. But for us, it means that we have to take the fleet renewal into account in our strive for climate neutrality in the road transport sector as a whole. Next slide, please. Already, and the next one, please, again. Already a year ago, all European truck manufacturers expressed their commitment to carbon neutrality by 2050 at the latest. Together with the Potsdam Institute for Climate Impact Research, one of the leading climate think tanks globally, we have laid out that carbon neutrality by 2050 at the latest inherently implies that already by 2040, all new commercial vehicles sold must be fossil-free. And we have chosen this term fossil-free very consciously. Together, we have, with the scientists, we have identified what the key building blocks are to set us solidly on this path to climate neutrality. The first, obviously, functional, reliable, and efficient vehicles are a key factor. This is clearly our responsibility as vehicle manufacturers. The second, a sufficiently dense network of charging and refueling stations to enable the operation of these new powertrains, trucks and buses. The third, and equally important building block, is a coherent policy framework which enables and drives the transition. This is key as a fundamental restructuring of this industry and ultimately of the value chains of all sectors that depend on commercial vehicles is what is necessary and at stake here, and it is already beginning. Let me dive a little deeper into this. Next slide, please. Now, reliable and efficient zero-emission vehicles are already beginning to hit the market. The new powertrain technologies will fast become the backbone of road freight transport. Truck manufacturers are investing heavily in the new solutions. Battery electric vehicles are the first zero-emission vehicle technology to reach the truck market, and these battery electric vehicles are closely followed by hydrogen-powered trucks. Now, road transport, especially with heavy-duty vehicles, is widely seen as a hard-to-abate sector, where cutting CO2 emissions is particularly difficult. And that is true, not the least because of our customers focused on total cost of ownership, the TCOs. The TCOs for low and especially for zero-emission vehicles just need to be better than they are for diesel trucks. Our customers need to be able to operate the new powertrain vehicles more profitably than their current diesel-based ones. If they're not, they will just continue to run the conventional vehicles. And this may be one of the reasons that some think electrification, be it with battery electric vehicles or with hydrogen-powered fuel cell electric vehicles, may still be far away in road transport. But that is in fact not true. The new powertrain vehicles are coming fast. Already by 2025, we will see a total of at least 40,000 battery electric trucks in operation in Europe. And by 2030, there will be several hundred thousand of zero-emission trucks, battery electrics and fuel cell electrics in operation. By the end of the decade, anywhere between a quarter and maybe up to half of all new registrations in some use cases will be in fact, will have to be zero emission if the infrastructure and the enabling conditions, the supportive policy framework, are in place. Contrary to popular belief, the majority of these vehicles will be heavy duties operating in long-haul missions, because this is where the majority of the emissions are. This is where we need to cut the emissions. Now, these vehicles obviously require a dense charging and refueling network that is fit for purpose. Every single one of them will require a depot charger at the home base, but in order to allow the variety of essential missions that these vehicles perform, we need publicly accessible charging and refueling stations suitable for trucks. A successful market deployment of the zero-emission vehicles will only be possible if a dense network of the appropriate infrastructure is rolled out rapidly. And this is, I cannot stress this enough, this is not a chicken or egg issue. The infrastructure must become available quickly as transport companies, be it in the road freight transport sector or with buses and coaches, need certainty that they can fulfill their transport missions. Truck manufacturers, in cooperation with fleet operators, will of course play an active role in developing the network of charging stations, but policymakers at the EU and national levels must take action to make this possible. Everyone needs to live up to the challenge that we're facing together here. As a matter of fact, and it has been mentioned before, clean electricity, hydrogen, and low and zero carbon fuels are crucial for the transition. Even though the additional power demand that the new zero-emission vehicles will need may be limited in total, we still need to make sure that they actually can be charged 24/7 at their individual locations with green electricity, with green hydrogen, and with low and zero carbon fuels. So all energy carriers that are used in road transport will have to be green and based on renewables as quickly as possible, not the least to allow contributions to the necessary emission cuts from the rolling fleet, the existing vehicle stock that may indeed take some time to get replaced. And this brings me to the last but equally important building block. Zero-emission vehicles will not take off as long as diesel remains cheaper. In spite of technology improvements and all our efforts, we see a persisting TCO gap for zero-emission trucks and buses and coaches. But as I said earlier, these vehicles will simply have to become the better option, the preferred choice of transport operators. And for this to happen, we need a comprehensive carbon pricing scheme which drives the deployment of zero-emission trucks and which adequately reflects the total costs of CO2 emissions. Science and truck manufacturers, together with the Potsdam Institute of Climate Impact Research I mentioned earlier, agree that the price of carbon must increase to much higher levels than today if we want to shift the sector to carbon neutrality. The truck industry here is ready to change and ready to lead this, but we can obviously not do this alone. We need deeper engagement and collaboration with policymakers, the entire value chain, and last but not least, also with citizens to navigate and actually accelerate this transition to climate neutrality. Thank you very much. Happy to take your questions.
Thank you, Thomas. Let's have a look at our Slido if we have any questions. But meanwhile, let me ask Stefan and Edel and Thomas to give us their feedback. Let's start with Stefan.
Thank you very much. So, Thomas, I was happy that you mentioned that zero emission is the best option also for heavy duty. But if we have a situation where this zero emission technologies do not work because of several reasons, then the second best option is to be fossil free, because this is the ultimate goal to deal with the climate change. So I was very happy about this argumentation.
All right, and Edel, what is your takeaway from Thomas' presentation?
I think, Thomas, you highlighted one of the points that could be really the Achilles heel if we don't fix it. Charging infrastructure, and charging infrastructure. This is really very important that we address it. You pointed out that the industry and the trucking industry are willing to lead the way, but they need this charging infrastructure and they need policy that supports. And this I very much welcome. I'm really glad to hear these reflected in your presentation.
Thank you.
So thank you, Edel, thank you, Thomas, thank you, Stefan, for your presentation. It was great to have you in our conference.